be honest with you.
All right, how's it going?
Excellent, Nick. I like your tie.
Thank you. If you haven't turned in your student info sheets, drop those off at the end of the class. If you need a sheet, I've got a few extra copies here. You can pick one of those up and turn it in tomorrow. Sign-in sheet is making its way around the class, and I'll send it around again when it gets back. And sign in at the end of class if you aren't here yet. So questions so far?
Actually, ask first and then Teresa.
Oh, Teresa reminded me. I completely forgot.
All right, so we're going to go through a bunch of stuff today, and we're going to move pretty quickly because there's a lot of stuff we need to get down before we can start talking about things like the next programming assignment and service learning project and stuff like that, which I want to get through this week so that you have time to work on them. So today our plan is to finish talking about GitLab. Okay, I want to go on to GitLab and show you how you set up the secret handshake so that you don't have to put in your password every time. And then I want to look at homework 1 and make sure everybody understands what the requirements are for homework 1, because this will be the prototype for turning in all of your programming assignments this quarter and probably next quarter. And then we'll talk about bash scripts, and we'll talk about basically how we put a set of commands into a file and some of the details we have to take care of to do that. And that will lead us up to ODP 402. So we'll look at that ODP in detail. It's due tomorrow morning at 8. We'll go through how to set that up. I'll show you the sample code that will work, and we'll go through an assessment of it. And then we'll talk about this weirdness with VI that happens sometimes where you try to edit a file and it yells at you and gives you a big message in red saying there's a swap file and should you recover or delete or all that nonsense. Basically, if you're editing in VI and your session goes away, weird things happen when you try to edit again. So I want to make sure everybody knows how to deal with that, okay, so that you don't have to look at that message the rest of your life. So any questions before we get started on all of that? Yeah?
So, which video we can watch and remains the class?
Which what?
Which video, where can I find the video?
Oh, they're linked on Canvas, so links to lecture videos. And Canvas doesn't want to look at it, so you can click through on the title. And there's a playlist there. So there's section A and section B, and they're dated.
Are we A or B?
We are B. So A is the first one and B is the second one. And they're usually the same material covered in each, but if you want to be absolutely sure, watch the one B for this class. Or if you want to see what we do before you get here, you can watch the A one. But it's usually the same material. And I'm writing the details on the A one, okay, GitLab, homework 1, basic scripting, and so on. I'm not echoing those on the B, but you can find it on the A. And if you ever notice a problem in these, let me know, because like I say, once in a while something changes and the audio disappears and nobody tells me. I did a whole talk to the engineering club and I had a different camera, and for half the talk the camera was facing the ceiling. And so I'm talking and I'm referring to things, it's just a picture of a few ceiling tiles. And somebody finally told me.
Very important information.
Yeah. All right, so let's go GitLab. Let's try it from this one. All right, so remember, I'm working everything in a separate directory. I've got a whole 224 directory for this class. I've got a directory called Git Work that I'm going to use for what we're about to do. So I'm starting a new project. Maybe it's homework 1, maybe it's, PA1 or something else. So one time set up git init. That creates a repository in this directory. Make your files. All right, I got 3 files in my project, main.c, function.c, and I got a readme. They don't do anything in particular right now. I want to put those under source code control. Remember the 2 commands I have to use for git? Git add. And since I only have those 3 files, I'm just going to say git add star. And then what's the second one?
Git commit.
Git commit. Question or?
Yeah, question. So what's the meaning of cd a work?
Oh, so when you log in, you're sitting in a default directory, which is /home/ your username. You can make new directories, right? So I created a directory called 224. I can say change my directory to 224, and now that's my current working directory. PWD says print my working directory. So I'm in this directory, and that has another directory called git work. So this is moving into that directory. And in that folder, I see these 3 files. We still have to talk officially about directories and moving around the file system and stuff.
Let's say that you're in the main directory. Can you go directly to Git work?
Yes. So if I'm in the main directory, I could say go into 224/git work.
Okay.
And it'll break me right there. All right, so we did our git add. Let's make sure what our status is. We've got 3 new files. We need to commit them, so git commit. And so if you don't do that global configuration for VI, your default editor is Nano, which is what this is. Some people prefer Nano, some people prefer VI. Nano does not have the weird single key commands that VI has, and so it's a little more, it's a lot more intuitive how to move around in here and edit in here, but arguably not as efficient, but that's okay. All right, so git status, everything is clean. So I had a typo in my function.c. I needed an extra slash in the beginning here. Okay, so I want to push that change in. So git add star. And when I do my commit, if I don't want to go into the editor and type in a message inside VI or Nano or something like that, there's a shortcut you can use on git commit. You can say git commit -m and specify what the message is you want to use here, and it won't make you type it in an editor. So git commit -m, just editing some files. And so that can be a little faster. All right, so we're doing all this stuff, and at some point you want to set this up on GitLab. All right, so you go to gitlab.com, you go to start a new account, you get yourself an account, you do the login, the email verification link and all that kind of stuff. And you log into GitLab and it looks something like this, except if you're just starting, you're not going to have any projects up there. So you need to do a one-time setup to let GitLab know who you are and let it know that it can trust what comes from your laptop or from your Linux server account or wherever it is that you're doing Git locally that you want to push over to the server. So you can be doing Git on the Linux server, which is what we've been doing here. You can do it on your own laptop. You can do it from your desktop system. You can do it from your phone. You can do it from whatever platform you have, a Raspberry Pi, a Mac, whatever. And each one of these, you might potentially want to take the code that's on that system and push it over to GitLab. And for each one of those, GitLab needs to know, can I trust what this device is trying to push over? So you set up this handshake between each of those devices and GitLab, and it will let it validate that you are who you say you are. Okay, so how do we do this? I updated the README, the how-to, and fixed the order on a few things, and reposted that on Canvas. So you got to do two things basically to set up this handshake. You only have to do this once per laptop, Linux account, whatever. Okay, it's permanent after that. The first thing is you have to do what's called generating a public-private key. And later on in 2.15, this quarter or in winter, whenever you take it, we'll talk about public key cryptography, and we'll see how this public-private key business works. But basically, you're generating a really, really long string that gets paired with another really, really long string. And one of these is secret, one of them is public. And the idea is if somebody has that public key, they can know whether or not you have the secret key. But they can't figure out the secret key from knowing the public one. It's kind of a one-directional thing. But you're going to take the public key and give it to GitLab. You're going to keep the secret key in an account on your device. And when you try to push something over to GitLab, GitLab will use the public key and it will find out if you know what the private key is. And if it does, it'll say, okay, you must be who you say you are. Go ahead and push your code over or pull this code down or whatever you're trying to do. So 2 steps. First one is to generate this public private key, and that's the SSH keygen command. So you're going to do this once. SSH-keygen-type RSA-block size 4096 uppercase C, and then the email that you used when you set up your GitLab account. And this is all in the how-to posted on Canvas. Make sure you spell keygen correctly. T says the type of encryption we're using is RSA. That's the type we'll study in 215, by the way. Block size 4096. Okay, it'll say generating public private key. Enter the file in which to save the key. Take the default. This is where you want it to be saved, so just hit enter. Usually Unix commands, they show you the default option in parentheses. If you hit enter, that's where it'll take it. Empty passphrase, hit enter for no passphrase. Take the default. And then enter the same one again, just hit the enter, and you're done with this. So you've got a public key now. You've got some fancy artwork you can put on your emails for people to use and so on. But what's happened here? What's happened is in a directory under your home directory called .ssh, there are now a pair of files, IDRSA and IDRSA.pub. And this is the public private key. So I'll show you what's in the public file. It's just this big long string. Right, it's 746 characters in there. So it's a really, really big password. And it goes with what's inside the IDRSA file, which is the private one, which I'm not going to show you. Okay, because if you have the private one, anybody who's going to authenticate with this will think that you're me. So don't give that out, don't put that in your emails. But the public one, you can put that wherever you want. That's public knowledge. Okay, in this case, what we have to do is we have to take this key, we have to give it to GitLab. So copy and paste. So I'm going to copy this, and on this terminal I can copy by just highlighting. And then on GitLab, click on your icon or your username, go to settings, come down here to SSH keys and paste what you copied into here. And it's got to paste as plain text with no extra carriage returns at the end of each line and so on. So depending on your system, you might have to fiddle with this. I seem to have good success with Control-Shift-V. So there's my key. You can give it whatever title you want, and then say Add Key. All right. So that's all we need. We're authenticated. The first time we try to push something, it'll tell us this is the first time we're doing this, so you need to tell me whether I should trust you this time. And once you say yes, it'll just do it automatically after that. Okay, fairly unsatisfying because we haven't really done anything that produces any exciting results yet, but we're about to. So let's go back to our Git work directory. And if you look at these instructions, adding your project to GitLab. When you're ready to push your project to GitLab, make sure you're in the project directory, that's what I just did, and then do the following: git remote add origin, blah, blah, blah. Okay, this is a one-time thing per project. The SSH key setup is one time per device. I've done that, I never need to do it again. But per project, you need to add your project to GitLab as a new project on the GitLab repository. So that's once per project. And make sure you do the .git at the end of your repository name. So for homework 1, you're required to make a repository called HW1. That's going to be git remote add origin git at gitlab.com your username /hw1.git. Okay, so let's pretend we're doing homework 1. Git remote add origin git at gitlab.com nickmacias/homework1.git. And that's unsatisfying too, it doesn't do anything. But it set things up so that we can push our repository over to the remote server. Okay, so that's a one-time setup. Anytime that we make changes, what do? We say git add, we say git commit. That updates our local repository. Got one more command when we want to push to the server, git push origin master.
So the other day, I accidentally already made my Git remote add.
Yeah.
And I can't figure out how to undo it. And
Yeah.
it just says fatal remote origin already exists.
Right, so git remote remove origin. Take a look at the how-to because I updated this last night after you posted that. But I think it's git remote remove origin. I'll take a look at it in a second. Yeah, git remote remove origin. And then you can do the add again. Because I do that so many times I forget the git and then it's like broken. All right, so so our status here, we're clean, we've got everything committed. We made some changes, we committed them and so on and so forth. Let's push it over to GitLab. So git push origin master. And this is that first time check, right? Because these two have never shook hands before, so we have to validate that this is correct. So say yes, and you're done. Okay, so what happened? Well, come back to GitLab, click on projects, your projects. Hey, guess what? There's a homework 1. Let's click on that, and there's the files that we had. And if we look at function.c, do something useful here. Well, that's what function.c says. And if we look at the README, it says, yeah, whatever. All right, well that's 20 minutes worth of setup plus everything we did before, but at this point we're all set for some really streamlined use of Git. So for example, let's make a real README. All right, so there's my real README. How do we push it into our repo?
Git push.
How do we save it in our repo?
Git add.
Git add. Git add README. Git commit. And then git push origin master. And we're done. So now if I come back to homework 1 and I say, let's take a look at README. Hey, there's the new version of README.
Huh.
And if I click on history, that was the initial version of README. There's a new version of README.
You're able to see both.
And you're able to see both. And you can, right, so that was the original one. And this is the new one. And you can download them, and you can compare them, and you can go crazy and do all kinds of stuff with this. Right? So it's the Git repository, it's just on a server.
So do we only need to have one key for going from the server to GitLab, or is it for each machine that we use?
It's one key to go from, say, my laptop to GitLab. It's another key to go from, say, linuxngrcs.com to GitLab. Mm-hmm. It's another key for my desktop to go to GitLab.
Okay.
You had a question?
Yeah, is there a difference between GitHub and GitLab?
Yes, so same idea, almost probably exactly the same commands. GitHub is older, I believe, and GitHub is owned by Microsoft. And GitLab originally let you have free repositories that were private, whereas GitHub did not. I don't know if GitHub has changed that since.
They're planning to, but not
They're
yet.
planning to? Okay. So since you want private repos so other people can't look at your code, GitLab's a way to do that. All right, and this is cool because now, you know, if I go to a different machine, that's authenticated, I can say Git Clone, and I can pull this repository down. For example, I think I can do this. Let's go to my laptop. Okay, so this is not the Linux server, this is my own laptop. Git clone git at gitlab.com colon Nick Macias / homework1.git, cloning into homework1. So it's created a new directory under my current directory called homework1, and what do I have in there? I have the code that I put on the server. And it's the latest version of all of that stuff, so there's the latest version of README. Right, and I can, you know, make changes to this. I got rid of README and all that kind of stuff. But none of that has affected, you know, what's on the Linux server where I was doing this work. I've got 2 copies of my project now. And from over here, I could do something like that. Right, and so on my laptop I made a version of my README that I made some changes to, and I pushed that into the repository. Well, if I go to GitLab and I look at the README, it's got my latest version. And if I'm on the Linux server, right, I've still got the old version of it. But I can pull down the new version from the repository and bring things back in sync. Okay, so what does all this mean for you? It means you can do homework 1, which is the goal. Don't make me log in again. Don't make me log in again. Yay. Alright, so homework 1, what are you doing? Get an account on GitLab, set up the SSH key pair, right, all that stuff. Make yourself a repository on your Linux account called HW1, uppercase H and W followed by the digit 1. Make a readme.md file, just VI, readme.md, and put a line or 2 in there telling me what your, you know, who you are and what your background is with Git, if any, or anything else that you want to tell me. And at your repository, git add the source code from ODP 401, whatever your .c file was. Go ahead and put that in there. So just copy it over to your directory, do a git add that thing .c, do a git commit, and then do the remote origin add, do a git push origin master, and you should have a repository sitting on GitLab with those 2 files in it. And it should only have those 2 files, readme.md and your ODP 401.c. Okay, and then there's one more step. It says, go ahead and add me as a reporter. So how do you do that? Go to your project, come over here on the left under settings, and find where it says members. Search for a member email address, so Nick Macias, that's me right there. Okay, it's not Nick Macias 3, just Nick Macias. I'm also Nick Macias 3. Choose a role permission. The role you want to choose is reporter. Okay, so reporter means I'm allowed to look at your repository. I'm not allowed to make changes. But this will let me make a clone of your files into my own system, and that's what I'm going to use to grade. So do that, and then just say add to project. And then I get an email saying that you've added it, and you're good to go. And then the last thing is go ahead and submit this. So if you do this in the student view, right, there'll be a submit button. What you want to submit is 1 line of text, which is just your GitLab username. Okay, and it's probably different from your Clark username. It's probably different from your email username. It's probably different from your Linux engrcs.com username. It's whatever username you decide to use when you create your GitLab account. It can be purple cow, it can be whatever you want, okay? But whatever it is, that's what you want to submit here when you turn in this assignment. And then I'll use that to pull down your repositories. Does that make basic sense? So you'd like to go home and try to do this today, and you know, ask questions on Discord if you're not able to get it to work, and if it's absolutely not working at all, right? I got office hours tomorrow morning, 2.5 hours starting at 7. You can come in and we can work through this on your account and figure out how to make it work. Okay? But by the time we get to class tomorrow, you want to have this process nailed because this is due Friday morning at 8. Okay? And Thursday night is not the time to start looking for help. All right? Because it's probably going to be a busy night and I'm not going to be online much anyway. So work on it today, ask questions tonight, ask questions tomorrow, ask questions in class tomorrow. By the end of class tomorrow, hopefully everybody has done this. Okay? It's a little bit of pain, right, up front, and then you're set. And then you never have to worry about it again. All right, so questions. All right, let's talk about scripting. Let me see. Yeah, ignore that. All right, so let's talk about scripting. Basic idea, which we've talked about already, is that a shell script is a file that contains Unix commands. And the idea is to take a bunch of Unix commands, put them in a single file. So instead of typing these commands, we just type the name of the file and it does all these commands for us. And Git is kind of a perfect example of where we might want to do that. For example, every time I change a file, I have to say git add, git commit, git push. Okay? I want to make that a little more streamlined. So I'm going to make a script that does all three of those things for us. And what should we call our script? Something that's easy and quick to type in. Script. Too many letters, 6 letters.
Yeah.
Yeah, okay. I'll do it with 2 A's. Script would be a good name too. So let's do yeah. So what do we want to do inside here? Git add. Well, I don't know what the file is that I might be changing. It might be readme, it might be main.c, but you know, I'm going to be lazy here. I'm just going to say add everything. Okay, this isn't really the tactical way to use Git, but it'll work fine. Git add star, and I'm going to say git commit. And remember, when you say git commit, it pops up an editor window for you to type in the specific reason why you're committing these changes. That's really important for bookkeeping, so that if you want to go back to the version before you implemented your brilliant idea and broke all of your code, you can look for the log file that says, you know, implementing brilliant idea, and say, okay, I want the version right before that. Okay, but we're going to be lazy and we're just going to use the message option and say, you know, saving work. And then we're going to say git push origin master. And the idea is every time I say yeah, I want it to do these 3 commands. Git add, git commit, and git push, which I just faked with a copy and paste. Okay, well, I should be able to just say yeah, but it's going to tell me permission denied. So what's this about? It would be kind of dangerous if any time you type the name of a file, it tried to execute the contents of that file. Because maybe you wanted to edit it, but you just typed its name by mistake. And if it happens to have something inside like rm star, it would remove all your files, right? So Linux will not execute files for you unless you do something to make sure that you really meant for it to be executable. So this is permission bits. Okay? Every file has, among other things, a set of bits that say who is allowed to do what with this file. And there's three types of things you can do to a file. You can read the contents, you can modify the contents, or you can execute the contents. And the world is split up into three categories. There's the person who owns the file, there's people who are in what's called your group, so other students in your case, and then there's the world, which is everyone else. And if I do an ls with an L switch, which says show me a long listing on ya, you see this series of letters in the beginning, RW dash, RW dash, R dash dash. Okay, what this basically means is that I can read the file, I can write the file, I'm not allowed to execute the file. That's what that RW dash does. People in my group can read, write, and not execute, and everybody else can read but not write and not execute. So if somebody who is not in my group or myself tried to edit this file, it would say permission denied. If anyone tries to execute it, permission denied. So we need to change it to say, okay, we are allowed to execute this file. So I'll show you the command for that. It's just change mod 755 and then the name of the file. And another day we'll talk about what 755 means and why that gives you execute permission. But it basically changes the permission mask to be read, write, execute for me and read and execute for everybody else. So when you're making a script, one time you've got to do this change mode command. And this sticks around as long as the file exists. I can log out, I can log back in. This file will still be read, write, execute. And I'll be allowed to execute it. So I can say yeah, and it'll go ahead, it'll add my changes, commit them, and then push them over to GitLab. All right, good with that? There's one other thing we got to do, and this is not easy to motivate, so you're just going to have to take my word for it. There are different shells, different of these programs we can use to interact with Unix. We're using something called bash. Okay, that's the name of the shell we're running. There's a bunch of other shells. There's the C shell, there's the TC shell, there's the Bourne shell, there's the Corn shell. There's a bunch of different shells. Any shell that we use, if we type in these commands, it's probably going to do what we expect. But when we start talking about programming, we're going to be doing if statements, and we're going to be doing looping statements, we're going to be dealing with variables. And the syntax for those differs from one shell to another. And at that point, it's going to be really important that if you're running the Corn shell, but you try to execute this script, it's the bash shell that's looking at these statements. Because I might write the syntax for bash, and the Corn shell might say, that's a syntax error. So we always put one thing in the very beginning of our scripts, and this has got to be the first line of your script. If it's not the first line, it doesn't do anything. So we put a number sign followed by an exclamation mark, that's called a shebang, and then we put in the full path to the shell that we want to use, which for us is /bin/bash. It's got to be the first line, no spaces, starting in column 1.
Why is that called a shebang?
I have no idea. And it won't seemingly change anything for us, right? We type in the name of the script and it still executes it. But if I was in the Corn shell and I said yeah, it would start a bash shell just to run those commands, which is what we want. And what is this number sign? A number sign is a comment. Right? Anything after a number sign is ignored by the shell. And I can say print my working directory and then remove all my files. Well, it comes after a number sign, it ignores it. Okay, so it's like a comment in C //. But there's this one peculiar thing, which is this first line of a script. Even though that's just a comment and is technically ignored, the shell will actually look at it. And if it's the first line, if it's a number sign followed by an exclamation mark, it'll say, let's run this program bin bash and feed it this line, this file of text.
Whenever I'm using it, it's saying that the -m is a known switch.
For Git Commit?
Yeah.
Oh, interesting. Are you on the Linux server?
I see my problem.
Okay,
I found it.
cool.
Typo.
Excellent. It's the best kind of bug to have. All right, so there's a shell script. And you know, this is an example of you know, so I'm being graded by how many lines of text I have, so I'll just make a whole bunch of lines of text, right? And then I want to add that to my repository so I don't lose my hard work. I just say yeah. And hey, it's off on GitLab now. Go over to GitLab and look at homework 1, and let's look at README, and there's my new README. So yeah, you got to set it up, you got to do the SSH thing and all that kind of stuff, but once you're up and running, you're typing your code, you're feeling good, you need a half-second pause, just say yeah, boom, you got a backup. All right, and you can go back, you can get old versions, you can restore them, you can copy your work to somewhere else, and so on and so forth. So once it's set up and it's in place, it becomes a really sort of painless thing. Just kind of sits on the side, but it's there when you need it. All right, so we are good to do ODP 402, so let's look at ODP 402. ODP 402, you are writing a shell script which will print out the words hello world, but it's got to be a cow saying hello world. Right? And it's a script instead of a C program. So you want a script that shows you a cow saying this. And there's a little hint on the bottom, use the cow say command. All right, so what does cow say? Cowsay is arguably the most important command in all of Linux. So if you say cowsay and you type something after that, you get a picture of a cow saying whatever you typed in.
Is that on all Linux servers?
The cool ones.
Now pipe it through lolcat too.
Yeah. And if you say cowsay, you can just type in stuff. And cow will say all of that. So yeah, we talked about pipes a little the other day, right? And a pipe is a way to take one command and say, instead of showing me the output of this command, send the output of this command to the input of another command. So we can use the date command to see what the date is. What's going to happen if we say date and pipe that into cowsay? We get a cow telling us what the date is.
Oh my gosh.
Yeah. So this is why Linux is the best operating system in the universe, right? Because you can do stuff like this. And yeah, there's also a command on here, lolcat, which will take its input and display it as a rainbow.
Whoa.
So you can get the rainbow cow telling you what
We
the
did
date
that for
is.
everything?
You can do that for everything.
Just pipe bash through it.
Yeah, basically. Right, so I can do ls-l/bin, pipe it into lolcat, and there's a list of all the files in the binary directory.
Is there a way to have lolcat just going all the time?
Well, like you said, you could pipe bash into it.
But
You have to
then
do a
that
little
breaks
bit of
the
tricky
text
work.
editors.
Yeah. But yeah, it's good SLP. All right. So let's do ODP 402. Yeah, question.
So when you do the command cowsay, then you do the tags, right?
Mm-hmm. Yeah, like cowsay,
How quick?
1, 2, 3, 4, 5, 6, and it says cowsay.
Last time.
Oh, so if you just do it like this, if you just say hello, cool, bye. So if you're typing an input to a command and you're done typing an input, usually what gets you out is Control D. So hold down the control button and hit D, and that says I'm done generating input. And we're going to talk a lot about that later, because that's going to be part of a bigger discussion. But for this ODP, we can just say cowsay hello world. So let's write ODP 402. So I'm just going to call this code. So what's the first thing we should put in our script? Yeah. Right? So that's like stdio.h for a C file. First thing we put in a shell script is always $!! /bin /bash. And cowsay hello world. The quotes are optional, but I really just wanted to say one thing, which is 2 words, so I'm putting it in quotation marks. It'll work with or without it. All right, cow say hello world, and that should do it. That should be my program. Okay, what do we do now? Are we ready to assess?
You gotta chmod it.
You got to chmod it. More particularly, you got to test your code. Okay. If I were to go ahead and assess this right now, assess code, and I say grade, I'm going to get a bunch of errors. I'm going to get 0 out of 10, and that's going to be really frustrating. Before you run assess, make sure your code works. Okay. So let's check our code and see if it works. Oh, it doesn't work. It says permission denied. Yeah, I got to do the change mod thing. Okay, change mod 755 code. Let's try code again. Hey, it looks like it works. Now I'm ready to assess. Assess code, and for scripts it's kind of silly. You just type in the name of the script twice. Assess code. It says I'm about to assess for ODP 402. Show a cow saying hello. That's right. That's the one we're trying to do. Let's go ahead and do a G to submit it for grading. 10 out of 10. We're done. Exit. Go on with your life. Right. So there's the code. It's a 2-line script. Again, the challenge is, getting this into a file, doing the change mode so it's executable, testing it, and then using assess correctly, and getting your 10 out of 10. All right, makes sense? All right, so here's one of those important points to pay attention to so that I don't have to say this too many times this quarter. Assess is not a debugging tool. Okay, the first time you write your code, that's not when you should try to assess it. If you really want to, you can, but you assess your code and you get 0 out of 10, there's nothing about the assessment that's going to help you figure out what the problem is. And sometimes you get 10 out of 10 and your code is still not perfectly right. It just means that I didn't happen to have a test case that caught your error. So before you assess your code, before you submit it for grading, test your code. Okay, this is really, really important. This is going to be increasingly important throughout the whole 3-course sequence. When you write your code, you want to test it yourself and make sure that it works. So at the very least, you want to just try running your code. But as the ODPs get more complex and they involve input and output and different conditions, you want to make sure you're thoroughly testing your code before you submit it. You can submit it 1,000,000 times. You can submit it, not get 10 out of 10, change it, submit it again, and so on. But I want you to try to get into a mindset where you're submitting perfect code the first time. Because the programming assignments, you only get one shot at submitting. Right? You submit them, you might submit them multiple times, but when the assignment closes, that's the version that's going to get graded. And I don't make a habit of looking at people's code and testing it for them before the deadline. Okay, I can answer specific questions, but it's not like assess where you can try 10 different versions until you get a grade you like. So you really want to get in the habit of how do I check this code, how do I make sure it works? So you got to think about test cases. And we'll talk about these in particular examples as we start working through more of the assignments. There's nothing to test here. It either works or it doesn't work. But when we start having input and so on, we'll have to start thinking about how do we know if this is going to work for every possible case. If it's expecting a number, what if the person types in something that's not a number? Or what if they hit enter and don't type anything at all? Or what if they type a number that's 50 characters long? Right, will my code do the right thing? All right, we've got 5 minutes. Last thing I want to talk about is the VI weirdness issue. So let's say we're editing our code and we're making some really good progress on it. I've added some comments here to get extra points and so on and so forth. And close your eyes for a minute. All right, something happens and we walk away and we come back 5 hours later and the cat has danced on our keyboard and there was a thunderstorm and our network got disconnected and we find that we're no longer connected to the server. Okay, so we go back into the server and we try to edit our code and we get this screen. Anybody seen this screen before? right? So this is really confusing. There's like so many words up here. What's happening is when you edit a file with VI creates a temporary file called a swap file to tell anybody else who's trying to edit this file, hey, somebody's already editing this. Because you don't want two people editing the same file at the same time. But what happened in this case was you were editing the file while I was editing the file, and my session crashed. And now I log back in, that file saying this file is being edited is still there. And it's like, hey, somebody's already editing this. Okay, so there's two possibilities. Another program may be editing the same file. That's option 1. Option 2, an edit session for this file crashed. That's what happened. Okay, so what do you do about this other than live with it? And I've seen people who get this for like, 3 weeks and they just keep living with it. So let's deal with this, okay? What's the first thing you do? Quit. Okay, hit the Q button, get out of here. Okay, and what I'm going to say is make a backup copy of your file before you do anything else. Let's just copy code.save, okay? One Unix command, but now I've got a copy of the file as it exists right now. Whatever VI decides to do after this, if it deletes it, if it fills it with random garbage, I've got a copy of the file as it is right now. Okay, that's just a safety thing. Now go back into the editor and try the recover option. Recover will try to get the file back to the place where it was when the session died, even if you didn't save it. Okay, so let's go ahead and say recover and hit enter. Okay, and there's the version. So I didn't save my other change that I made. If this looks good to you, go ahead and WQ. If it doesn't, right, then go back to your save file and figure something out. But almost always this is going to look good to you. Okay, edit your file again, and it's still telling you there's a problem, there's another file out there. Now you can say delete it. Okay, so hit a D to delete it, quit out of that, and now when you try to edit your file, you don't have that annoying message anymore. So if you get that message, quit with an uppercase Q, make a manual backup copy somewhere, edit again, say recover. If that looks okay, edit again and say delete. And then you're back to where you were. And my code.save, was exactly the same thing, so I can get rid of that or I can leave it around. Make sense? All right, so tomorrow we'll talk about questions, we'll talk about ODP 403, and we'll start talking about programming and shell scripts, input, output, looping, conditionals. All right, and variables, and it'll be good stuff.
Is 2:15 is the same place right there?
2:15 is here in 40 minutes, 12:30.